Okay, here is part 3. This is the rational root theorem. Rational because we have a ratio, and it's the ratio of the factors of the last. Let's write it there. Factors of last divided by Q is the factors of the leading coefficient, are the factors of the first. Okay, that is going to tell us what are possible rational roots. Some of these, when we do P over Q, might not be a root, but if they are a root, it must be one of the ones we come up with. So let's try it for this problem. The possible rational roots, P over Q, is factors of the last divided by factors of first. Well, the factors of the last, the factors of 16. 1 times 16, 2 times 8, and 4 times 4. Those are all the factors of 16. What are the factors of 1? Well, that's only 1. So our possible rational roots are plus or minus 1, 2, 4, 8, and 16. Well, now comes the hard part. We want to test something. These are our many options, but that's better than testing the entire universe of numbers. So let's go ahead, let's try it. Now I'm going to use a little bit of some other things I know about them to kind of lead me along the way. We'll spend another day on this and we'll learn some more rules to help us narrow down this list. But let's just go ahead and start. I always start with kind of one of the numbers in the middle. Okay, so I'm going to put 4. Now I write down my coefficients. 1, negative 5, 12, negative 24, 32, negative 16. I could have chosen any of these, but I just decided to start with 4. It's positive, easy to work with, it's kind of in the middle. So, do my synthetic. Bring down 1. 1 times 4 is 4. That's negative 1. That's negative 4. That's 8. That's 32. That's 8. That's 32. That's 64. 64 times 8. Wow, that's a big positive number. This is going to be positive. It is not equal to 0, right? It's going to have a remainder. So x cannot equal 4. The other thing that I'm going to learn tomorrow is if there is one of these is a negative, it's not all positive, I could have a bigger number, okay, since these are not all positive. So that tells me that maybe now I'll try x is 8. Start again. Okay, bring down 1. 1 times 8 is 8. That's 3. 3 times 8 is 24. That's 36. Well, that's going to be a big number. 6 times 8 is 48. That's 288. That's going to be a big positive number. Then I'm going to multiply by that. That's going to be a big positive. That's going to be positive. That's going to be positive. This is going to end up being positive, right? Because I'm going to do 288 minus that, right? That's going to be like 250 times 8, and then add 32, multiply that by 8. Wow, that's going to be a big number. These are all positive numbers. X can't equal 8. These are all positive, so now I've learned not only that x can't equal 8, but I also know that anything higher than that, since all positive, x is 8 is too high. So the good thing is I learned not only that x can't equal 8, but I also learned that x can't equal positive 16. I'm going to have to try something lower. So let me try 2. 1, negative 5, 12, negative 24, 32, and negative 16. So I'll try positive 2, 1, 2, negative 3, negative 6, 6, 12, negative 12, negative 24, 8. 8 times 2 is 16, 0. Oh, hooray! The remainder is 0. Therefore, x equals 2 is a root. So now I have something. Let's see, I started with x to the 5th. So now I am going to work with this new line, which is, this is something x to the 4th. So that's what I'm going to use. You must use new line because we want to keep on depressing it to a lower and lower value, ideally down to a quadratic where we can solve. Okay, so I'm going to write 1, negative 3, 6, negative 12, and 8. So my choices are to do any of the negatives, and also I can use 1, or I could also use 2. I could use 2 again because it could be a double root. Let's see what happens when I use 2. This is kind of, I'm jumping ahead because I know that this is going to work. 1 times 2 is 2, negative 1, negative 2, 4, 8, negative 4, 2 times negative 4 is negative 8, that's 0. That's our remainder. X is 2 again. Now, this was x to the 4th. Now I've reduced it to x to the 3rd. Do you see this pattern right here? So I really have x to the 3rd minus x squared plus 4x minus 4. Now, I could keep on doing synthetic division, or I could notice right now that that is something that I can factor by grouping. So I'm going to do that. Factoring is always simpler than anything else. So x squared plus 4 times x minus 1. So I now know that I have a root, x is 1. I have a double root, x is 2. I'm going to write it twice just so I can keep track. And I also know that I have x squared plus 4 equals 0. X squared equals negative 4. X square root that. And I'm going to get x equals plus or minus 2i. So there are my 5 roots. Remember, the degree was 5. So I should have 5 answers. Now, some can be repeats, as in this example.